Good evening, everyone. My name is Kelsey Webb, and I would like to welcome you back to another Tech Talk in our series sponsored by Codesmith, Genie, and Bracklet. Today, we have the pleasure of welcoming Eric Dalio to give us a brief talk about design patterns. So without further ado, I'd like to pass it on over to you, Eric.
Thank you, Kelsey, for that kind introduction. And also thank you for the opportunity to speak with everybody today. I want to make sure and thank our sponsors of the talk today, Codesmith, Genie, and Bracklet. So today we're going to be talking about design patterns. And starting off, what is a design pattern? Architect Christopher Alexander, whose theories about human-centered design influenced many fields, including software design, he said, each pattern describes a problem which occurs over and over again in our environment, and then describes the core of the solution to that problem in such a way that you can use this solution 1,000,000 times over without ever doing it the same way twice. Now, here he was talking about buildings, towns, cities, but these patterns carry over. And so when we hone our focus to software design, we can think of them as design patterns as customizable solutions for commonly occurring problems. So why use design patterns? Here we see interrelated concerns that are very common to software designers and engineers, right? Scalability, flexibility, new or different approaches, adaptability, modularity, all things that are thought about. You know, if we're building something for our current situation, that doesn't always prepare us for tomorrow's realities. Design patterns can help us to identify new or less obvious problems and solutions. Design patterns can also help us to anticipate new or changing requirements. And a process of intentional and thoughtful initial design ensures that a system can be altered with less overall impact because parts of the structure can change independently. So, types of design patterns. There are 23 design patterns, and they can be divided into 3 categories. We've heard about a few of these already in previous talks in this series from some of our brilliant colleagues. And so if we look at these 3 categories, we have creational, we have structural, we have behavioral. And zooming in on the creational here, they talk about how classes or objects are created. So we have the abstract factory, the builder, the factory method, the prototype, the singleton. And so looking at one of those, the creational, in the creational category, we have the abstract factory. And so the abstract factory provides an interface for creating families of related objects that do not specify their concrete class. So for example, if we had a car app of some sort, and we would build an interface that is our car abstract factory that would produce methods for a sedan, for an SUV, etc. And then we could use that to build concrete factories for brand A, sedans and SUVs, brand B. And so this allows us then to have easily interchangeable components. We can add brand C, we could take it away, we could change it, add brand D without impacting the overall structure, all stemming from our car abstract factory interface. Looking at structural design patterns, how we build with and create, or how we build with and relate classes or objects into a larger structure. The adapter, the bridge, composite, decorator, facade, flyweight, or proxy patterns. So here zooming in on the adapter pattern, just like it sounds on our phones, our headphone adapters, all those things. It converts the interface of a class or an object into another interface that clients expect in order to correct incompatibilities. So for example, if we have built some sort of reporting application, maybe sports scores, stats, stock market, whatever it may be. And we get that information from a third-party provider. And it's in all, using XML. But then we want to add some features. And so the features library, we choose working with JSON. So instead of, rewriting code here or refactoring our original application, maybe causing headaches and things to break, we can think about an adapter pattern that will make this connection. And third category, we have behavioral patterns. And in behavioral patterns, we talk about how classes or objects interact and distribute responsibility. The chain of responsibility: command, interpreter, iterator, mediator, memento, observer, state, strategy, template, visitor. Things, that are, some of these are familiar to us as software engineers. Here we take a look at the mediator pattern. And it can do exactly what it sounds. It mediates, right? It reduces chaotic dependencies by encapsulating details for how a set of objects interact into a single point of contact. So on the left, we see an example of many components all talking to each other in various different ways. So if we make changes to those components, it could have, a cascading impact on our system and cause headaches for us or cause breakdowns. So thinking about a mediator pattern to solve this problem, it makes it much easier to make changes to components and with less impact on the overall system. So when we think about choosing design patterns, can be quite overwhelming when we first look at these and, first dig in and start digging through that information. So it's important to kind of focus in on 4 essential elements. Now, depending on the resource, they might have different wording, but the concept remains the same. A pattern name, which is a description of some sort, like we already saw, adaptive pattern, abstract factory, right? A problem. The problem outlines the problem and when to apply the pattern, when it might be helpful. The solution. This provides a high-level overview of a design problem and a general roadmap for solving it. Now, this is an important point because these are not copy-paste solutions. It is a blueprint that can help us solve problems and be creative, give us an idea for how we might be creative and solve it as an engineer specific to our situation. If thinking back to that original quote, it can be applied in millions of different ways. And then, of course, thinking about the consequences of employing that pattern. What are the results going to be? What are the pros and cons of using that pattern in this situation? So why use design patterns? Some of the pros of using design patterns, we've heard a lot already. Scalability, adaptability, flexibility, modularity, making our systems easier to make changes. It can give us greater insight and understanding of problems and possible solutions. Possibility for new and different approaches. Solutions we might not have thought of, or maybe as we're looking through, we might see a problem that we didn't even know was there. So it can be very useful in those situations. It also provides a common language for discussions on your team. If you're all grappling with a problem and you're talking to a teammate, very easy to say, well, maybe the adapter problem would solve your issue. And then, of course, that can lead to very efficient and clean code that's very easy to understand. Now, of course, there's cons. There can be a steep learning curve for new learners and experienced engineers alike. There's a lot of information and it can be very dense. And another issue is that oftentimes initially approaching design patterns, people, have used them just as kind of quick shortcuts, thinking of them as just like a quick copy paste solution, which can lead to kind of messy and difficult to read code. So they do require intentional and thoughtful design, right, to make it really work well. That kind of like measure 9 times, cut once to make it really work, which, under the pressures of deadlines and budgets, can be a difficult sell to get people to buy in. So in summary, design patterns, they provide solutions for common problems. They address creation, structure, and behavior of classes and objects, and they allow for flexibility, adaptability, and scalability. As far as works cited, if you'd like to know more, these are some of the things that I use. I would really like to highlight, especially the first 2. Those are very, very rich. This book and on the web, many other resources are out there, but many of them are kind of derivative of these things, not to be throwing shade, of course. But I'd also like to shout out Refactoring Guru, because they have a ton of really useful information, and also diagrams and images, that some of which we saw in this presentation today. So I really want to thank everybody for their time. Please reach out, connect. If you have questions, if you'd like to discuss design patterns further, I'm always open and would love to hear from you. My information is here. And with that, I'll pass it back to Kelsey.
Thank you so much for that informative talk, Eric. And thank you everyone for coming out tonight. We will see you at the next one.